welcome to my bench. Today we got a new little toy. This is a Sencore, the Substitutor. It's a resistor and capacitor substitution box with built-in rectifiers. And this one I got off of eBay for a decent price. It's interesting cover. Something's on the front here, but it came with even came with a little box, a little tray underneath, like if you can see it here, for storing parts. And it comes on this little swivel, which I'm gonna have to tighten up a little bit, but it's nice. I've wanted one forever. I have this one of these things that if I can get it, I got one of these, which is okay. It's a little bit scary in the fact that when they're all down, it's a short. So don't, it can throw you out a little bit, and it's not tremendously accurate, but it's good enough for what it is, I guess. I also have this thing that I built, and it's just a little bunch of capacitors, all inside this old case, power supply case for a computer that was dead. And it's okay, but it goes down to 42 picofarad. The internal capacitance with the leads is higher than that, so that's worthless until you get up to about 60 or 70 picofarad up here. One of the nice things about this is it is a decade and it does add, but that's of limited use actually. And it does have off, so these are open when there's nothing, when they're all off. And this works okay, but it's meh. It's all right. No complaints, but it's not real good for being in circuit. And I found this on eBay, and I said, you know what? This looks like it would be fun to play with. So I want to find out. We're going to check it out and see what we got as far as how bad this thing is. And I have a feeling that it's not going to be real good. These things usually got kind of put through the grinder as far as being abused, because this one says it's got 1 watt resistors from 10 to 5.6K and half watt resistors from 10,000 through 5.6 mega ohms. And over here it's got wire wound resistors, which are from 20 watters from 2.5 ohms up to 150. And then when you put this on 100 times, there's still 20 watts. And so it would be 250 to 15K, right? Yeah. 1500, yeah. And those are probably okay. The capacitors, I don't know. It goes from 0.0001 up through 0.5 on this dial, plus a selenium rectifier at 0.5 volts, 800 or 0.5 amps, 800 peak voltage, and a silicon rectifier, which it connects down here. And it also has electrolytics over here, which go from 2 at 450 up to 2,000 at 75 volts, and a 200 at 450 up here, and a button that is a little discharge circuit. If this little light comes on, your capacitor is charged. Don't push the button until you're ready, until that light goes off. And then it holds itself down here with a little notch in the metal. So we're going to see where it's at. Okay. A couple of leads we're not going to be real horribly accurate about this because I don't have to be really. Like I said, it's a substitution box. You don't expect it to be fantastic or perfect. It's just got to be close. Now I got a new toy. I'm doing this whole thing on a whole different way. By the way, all of my videos in previous times have been individual cameras, all with individual files. When I got done, I had to download all the files off the cameras into the computer, and some of those files for a half-hour video were 9 gigabytes, and it takes a while to do that kind of stuff. Plus, I had to take another camera to point it at something like the meters or whatever, to get it. Well, I finally decided. I bought myself a decent overhead, and I got a where is it? I got a meter, so we can read this stuff right here on the screen. See? Yay. And I'm doing this all in OS, Open Source Broadcaster. So this is going to be a completely different way of doing it. I don't have to put everything together and match up voices and match up video so that the action that you're seeing and what I'm saying go together. It just sort of all goes in one file. I don't know if I'm going to like it, but we'll find out. So let's hook up this thing to my meter and put it on 10 ohms. What? Okay, first of all, let us, like I said, we're going to be doing a little bit differently this time. Let's move this over so I can see it. There. Okay. Minus 27.7 mega ohms. That can't be right. What am I on? I'm on ohms. My meter is not reading. Ha! See? Well, that's cute. Oh, okay. I don't know. It was just stuck there. It did shut itself off, so we'll find out. All right. This is not the fastest meter in the world, that's for darn sure. And all right, finally got them all connected. So on the first one, it says what? 12.9 ohms. Yeah, a little bit. What does our meter actually read? Just putting the leads together. About 0.4. So we're 0.4 ohms putting the leads together, and 12.9 on the 10 ohm range. Wow. Okay, so that's a little high. It's a couple ohms high on 10 volts or 10 ohms. 18 ohms. We got 21.7. That's a little high. 33. We got 38. That's a little high, but these are, I don't know if these are 1% or what. I doubt it. But it's too high for me. For 56, we got 62. That's definitely too high. 100, we got 117. That's gone up some. That's 17 ohms above. Wow, okay. 180, we got 208. Ooh, that's 28 ohms. And on 30, we got 408. Wow, they're getting worse. 560, we got 784. Oh, these are really good. getting bad. The 1K is 1.9K. That's 2K. That's double. That's double what it's supposed to be. That's not good. 1.8 is 1.796. Holy smoke. Unusual value. Nobody uses it for anything. So it's still there. 3.3K is, wow, 7.5K. Yeah, I'll bet you that one's burnt. And 5.6K is 7.26K. I'll bet you that one's burnt too. So let's take it around and try the times 1,000. Times 1,000 on, this has got 13.8K. That's 3K higher than it's supposed to be. 18 is 19K. That's 33K is 39K. And these are, I believe, are just individual resistors in here. 56 is 60K. 100 is 112K. 180 is 190. Oh, my Lord. 330 is 370. 377. 573. Well, 560 is 574. 1K, so it'd be 100K, so 1 meg. Wow, the 1 mega ohm is almost okay. It's only 90K out. Well, 84K out. And the 1.8K with 1.9, somewhere around there, mega ohms. Like I said, that's close because it never got used. The 3.3 mega ohms, 3.8, and 5.6 mega ohms is 6.4. Wow. Okay. Well, I can tell you right now, they all need to be changed. Let's go over here to these guys, to the power resistors, and get these. Okay, so what do we got here? 2.5 ohms. Well, you take our 0.4, you got about 2.6, so that's okay. The 2.5 is fine. The 5, take away the 0.4, okay. 5.1, that's good. 7.5, okay, so 8.1. 10 ohms, 10.4, 10.0 on the nose. That's not bad. That's good. 15, 15.1 when we subtract what the meter's showing. And 25 is 26.2. That's a shade high, but I'll live with that one. That one's fine. 50 ohms, 50.8, so it'd be 50.4. Okay. These are 20-watt resistors. Big sandcastles, probably. 75 is 76.5, so it'd be 76.1. Okay. 75, 76 ohms. That's fine. And the 100 is 103. Couple high. And 150 is 155. It's about 5 high. Well, I could still live with that. They're 20-watt resistors. So what do you got? 2.5. So it'd be times 100. So 250. Okay, 249. This would be 500. 486. Meh. It's a little low, but it'll do. This one is what? Okay, so what? 7.5 is 735. Oh, there we go. 735. Okay, that'll work. The 1K, which would be 1000, which would be 1K, 992. That's pretty close. 1.5, 1.507. That's darn close. And the 25, 2.508. That's good. And 5K is 4.872. I'll live with it. The 75, so 7.38. Okay. Little low. And 9.8 on the 100, on the 10K. That's a little low, but it's like I said, they're power resistors. And 14K, 14.77, that's okay. I can live with that. So those guys are, for the most part, all right. Okay, now, I don't know how this meter does capacitance. Let's see, we're on capacitance now. 0.022 shorted. Does this have to be on? No, it doesn't. That's interesting. All right. So we go back here. So we got a 0.1 nanofarad. The auto finally took over on the meter. I don't know how good this tech meter is, but for voltages, it'll be okay, I guess. So 0.13, that's okay. 0.5, so 0005, yeah, that's fine. 0.1 nanofarad, so 0.001, that's good and close. 0.0025, meh, that's good enough. 0.005, 5.24, shade high, still okay for government work. Remember, you're going to be clip leading this thing into a circuit anyway, so it doesn't make that much difference. 9.5 on okay, 10 nanofarads. Well, okay, close enough. The 17. That's a ways out. That's supposed to be 20. And that's 17. Yeah, that's a little too far. Probably have to change that one. So that's a 0.05, 0.02. Yeah, I can change that one. And 0.05. That's pretty good. 0.51. And come back up to 100. There's 100 nanofarads. It's 105. Okay, close enough. And 0.5. 496. Yeah, that's nice and close. Now, let's go to diode and test the diodes. 495 on the, what it says is selenium, and 485 on the, what it says is silicon. Let's see what they look like backwards. They are open and open. Ah, okay, well that's good. All right, and on to the last. And hook this up here and here. And we're on two microfarads. These are the electrolytics. 2 microfarads. And we got 2.3, no, microfarads, dummy. Put it on the right one. Okay. 1.9 something and dropping. Okay, it's 450 volt, 2 microfarad. 5 microfarad. Yeah, no, that's 10. 9.6. So 5 is way out. 10 microfarads is 89. Yeah, no. Yeah, I don't trust this thing. Not for that. So let's this meter, this tech meter, apparently doesn't do a real good job. Let's see if I can get my other camera here working. I've got another camera that's designed to be pointing at the bench from off to the side a little bit so that I can do stuff like this. And we'll see if I can get it to work. How does that work? Yeah. That's going to be a lot of glare. All right, so we bring up this camera. Boink. All right, there we go. I'm on my little meter here. This is a what do you call this thing? It's a digital meter for capacitors, resistors, diodes, and inductance. So let's see if we got here. This one is not auto ranging, so we're down at 2 microfarad. Got to plug the plug leads in all the way. All right, there we go. So there we go. 2.2, 2.24. Meh. That's on the 20 scale. Okay, so that's 2 microfarads. The 5 is at 3.5. Okay, so we got 3.5 on the 5. That's low. We got about 8.7 on the 10. That's low. We got about the same thing on the 20. That's shot. The 50. $54. Take this back down to the 20 and see what it reads on this scale. Now it's shot. The 20 is totally shot. The 54 is 50 is a little high at 55. The 100 is shot. Definitely. So the 100 microfarad is toast. And the 200 microfarad is toast. Go up to 500 microfarad. Yeah, it's 550. Baby, yeah, it's okay, but it's 500 to 75. I think I have one of those. Well, whatever. The 1000 is 1,000. Holy Hannah, I did not. I'm okay. I didn't expect that. And the 2000 is not readable on this device. 2,000 microhenries, or 2,000 microfarad. Well, I'll replace it anyway. I guess. Okay, well, there we go. It looks like I got a lot of capacitors to change, and a lot of resistors to change. But let's see what kind of a job that's going to be. God. All right, how do you get this thing open? Well, the screws over here. All right, there's screws there. And there's screws here. That one was loose. How do you fit in there? Oh, like that. Okay. Oh, a little bit of dust, rust. Not bad. Very good. It's like not in that bad a shape. Let's put this down here. And let's see what this looks like. Oh. Okay, well. This is cute. It was Dave Jones would say that definitely smells like the 60s. Okay, so let's go with the resistors first. The resistors appear to all be 1 watt and half watts individuals, and the half watts or the 1 watts go from this set of this switch wafer to the common. And the half watts go from this switch wafer here back to the common. So they are all individual resistors. And oh, goodness gracious. All right, let's see if I can show you this. Come on, light. Looky. Come on, focus. Right there. Yeah. That's not looking good. Some of these are definitely burnt. What is that one? Well, it starts with green. I can't really tell what it is. Let's see if we can measure it. All right, let's see. Bring meter back up. Right there. 1.1 megohms. Okay, well, evidently that's not green, it's brown. What's this one under it? 1.9K. And that is definitely burnt to a cinder. And this one here, so how are these organized here? That one's 500K. And this one that's above it right here is a 1 meg. And this guy below the 1 meg should be 1K. It's burnt to a crisp. 1.9K. So, no. This thing is reading incorrectly. Let's see. Here's directly at my meter readings. Right at the probes. Yeah, that's the 1K resistor. So the one that's burnt to a crackly crunch down here is the 1K resistor. And the one right above it, is that the 1 meg resistor? That's the 1 meg resistor. So, all right, so now we know where we start. Okay, well, this is going to be, yeah, everybody gets replaced. That's just all it's going to, you know, all replaced. So a bunch of 2 watts and 1 watts and 1 watts and half watts. Maybe I'll go 2 watts and 1 watts. That would be nice. Give myself a little room. Over here, as far as these guys, these sand resistors are all fine. I'm not going to mess with them. They're good. The capacitors, well, this side of the capacitor setup here is one of these big brown drops that is, I can't see it without some light. It is 600 volts, 0.5. So that's the 0.5 at 600 volts. There's a 0.1. There's a 0.05. These have got to go. That one's probably fine. The rest of these are pretty good, I think, except for one of them was way out of tolerance. And the diode, I can't even see where the diode is. Oh, there's the diode. The diode is right back there is a diode. We're right there. And it does not appear to be a selenium. I think they're lying. That's just a solid state diode. Can't see the number on it exactly. And as far as the electrolytics go, they are a complete total lost cause. Oh my, you've got, okay, so we got this one cap here, this one big barrel cap has 1, 2, 3, 4, 5, or 6 in it, and a common ground. That's got to go. This one's got 3 and a common ground. What's these guys here? One of them's leaking its guts out. And what is that? That is 1,000 and 100. So how does this work? Because there's nothing here that big. Okay. What they do is they take... Yeah. I'll bet you if I get the schematic for this thing someplace, they take... This is a dual 500 at 100, so it's got 500 and 500 on these leads, plus ground, and this is 1,000 at 100, and it's leaking. There's little guts out, front and back. It's nasty. So what they do is when you go to 500, it cuts in one of these, parallels up another 500 for 1,000. So evidently this guy is fine. Not going to stay in here. And then on the third position, they parallel in this guy for 1,000, which gives you 2,000 microfarad total. And this guy is not looking good. Let's see if we can even measure this thing. That is the 1,000. Get this off of. So it's reading about 1,128, but boy, I wouldn't trust that thing as far as I could throw a brass toilet. No, that's got to come out. So what we need to do is I need to get online and order a bunch of little parts. Whole series of resistors, everything's getting changed. Both of these caps, all those got to get changed. And that cap there, I'll bet you it's got everything from 2. What's the last one? The last one's a green one, and it's 5. Okay. So 512. Okay, 512 and probably something up. Yeah, and they also add a couple. Let's take this off of here real quick and find out. So they don't just put individual capacitors in here. What's this one? This big one's got 55, 33, 12, and 5. So 55, 33, no, 5, 12, 33, 55. 5, 12, 33, and 55. That's interesting. Okay. So they are adding them up in bunches to get them. Okay, and then this one, I can't even read it. They smashed it down. It's got 120 microfarad and 2 more values. Yeah, I'll have to get a manual and look this up and see if I can find it. But yeah, those are getting changed, and they're all going to get replaced with new moderner ones. These 2 guys got to come out of here for sure. This one's probably, I know that's fine. And all the resistors. So there's a bunch of work to do on this little box. That's going to be fun. Anyway, when I get the parts in, I'll come back and finish this up. That should be a nice long one. Anyway, there you go. There's a Substitutor from Sencore. It's evidently been through the ringer a few times, and somebody decided that 1K and 3.3 and 5.6Ks were definitely sacrificial lambs to burn up because they are just gone. The switches are in good shape. The rotary switches are all in good shape. Some of them are sealed. This over here, this is a resistor and a diode connected to this to the negative and one side of this switch when it's in its released position, so that you will go through this. You'll light this light and discharge a capacitor when you put it on there. So that's to make it safe for you. So anyway, so there we go. When I get the parts, we'll have another video and make this thing as good as it ever was, maybe better. Hey, thanks for watching. Give it a thumbs up if you like it. Let me know in the comments what you think of the new format with the new cameras and things, and don't forget to subscribe and ring that little bell if you want to know when I'm doing more. Till later.